In this video, we want to evaluate the integral given here where the integrand is a rational expression. Now, you're given a big hint here. It says first simplify the integrand. So we got a 2x plus 4 indeed. So we can factor a 2 out of this one. We get x plus 2. The denominator, we have a cubic polynomial. But notice from these two terms, we can factor out an x squared. That gives me x plus 2. But this is the last two terms, 9x plus 18, I can factor out a 9 out of that. I'm left with x plus 2. Now take out the x plus 2. So we're actually factoring this by grouping. Take out an x plus 2 here. The first group leaves me with an x squared and plus 9. So taking out the x plus 2 from this part here and the x plus 2 from this group right here. Break it out, that leaves me with the x squared plus the 9. So I can cancel this x plus 2 with the x plus 2 in the numerator. So this becomes the integral of 2. I'll put the dx over here. And all I have in the denominator is this x squared plus 9. So this is not going to be partial fractions. The integral simplified. That's why, even if it doesn't say in this particular problem, it gives you a hint to simplify the integrand. Sometimes it won't say that, but that's the first thing you want to do. Can you simplify the integrand and make the problem a little bit easier? Well, in this case, it makes it a lot easier. You don't have to mess with partial fractions for this one here. This is what we have. And you should recognize this as the integral that leads to the inverse tangent. In other words, if you have integral in the form du over u squared plus a squared, where u generally will be a function of x, and the a is constant. You got something in that form, the value of that integral will always be 1 over a, and then it'll be arctangent, or you can call it tangent inverse, whatever u is, over a. And that'll be plus the constant of integration. So in our case, we have the integral then. 2 is a constant, so you can look at this as, in this case, the x is actually going to be the u. Got x squared, the 9, that's your a squared. So in our case, that tells me that I'm looking at this formula. In our case, the u is x, and the a squared is 9. So a in our case would be 3. Bring the 2 out in front, it's constant. So this would be the integral of dx over x squared plus 9. And it is just this formula here. So this would be, remember you have the coefficient 2. A is 3, so this would be 1 over a. In our case, that'd be 1/3. But you got the 2 there, so that'll make this a 2/3. And then multiplied by the arc tangent of u over a. In our case, u is x, so this would just be x over a. A is 3. That's plus the constant of integration. So the final answer to this one is 2/3 arctangent of x over 3 plus the constant of integration. Now, you can check these answers. Sometimes the check is longer than actually working the problem out. So just for your information, let's go ahead and check it. You can stop here if you don't want to see this, but this is the answer. So we're supposed to take the derivative. To check it, we take the derivative of the answer, and we have to get the integrand. Obviously, the derivative of a constant is going to be 0, so no problem there. And the formula for the derivative of arctangent of u, this would be the u in the formula, is simply the The 2/3 is constant, so that comes along for the ride. So that'll be 2/3 here. And then it's the derivative of u. This is u here with respect to x. So the derivative of x over 3 is just 1/3. I'll just put this up here. And then for the denominator, it's going to be u squared plus 1. Well, u squared in our case is, or 1 plus u squared, either way. So 1 plus u squared, that's x over 3. So that'd be x squared 9. And then we multiply. To simplify this, multiply the denominator by 9, the numerator by 9. So this is going to give me 9 plus x squared, because the 9 here cancels up with the x squared first. So this will be x squared plus 9. And in the numerator, this is actually going to be 2 9s, so the 9s cancel out. I get a 2. And of course, you just have to remember what you did to simplify. What did we do? We canceled out an x plus 2. So multiply this by x plus 2 and multiply the denominator by x plus 2. And then multiply this out, I get 2x plus 4, which is this part right here. And if I multiply this out, x squared plus 9 times x plus 2, you will get, simplifying, you will get the denominator. Anyway, this is your answer, final answer here. Thanks for watching. We'll see you next time.